we're going to examine linear modeling, regression, and correlation, and we're going to start by looking at linear modeling. By the end of this really short video, I want you to be able to distinguish the difference between exact and approximate models, discrete versus continuous, and I want you to be able to make a scatter plot. When data fits a line perfectly, you can use 2 points to write an equation of a line. And so when you first go to write that equation, you need to find the slope. So I might have the points 1, 2, and 3, 5. And we would subtract the y values, and we would subtract the x values. The key is when you're finding slope is that you're looking to see if there's a constant difference in the y values for a uniform change in x values. So you don't want in a table x to be counting by 1s, and then suddenly it counts by 2s, and then it goes back to 1s again. Otherwise you can't really find the slope. If, however, we find that the difference in the y values are almost constant, then we'll consider it approximately linear. Let's look at 2 examples of this. Let's look at an exact example, and let's look at an approximate example. So here you see 2 examples. On this first one, if we look at the first differences here, we see that the first differences here are always 2. So x is changing at a constant rate. It's uniform. It's always going up by 1, and the first differences are the same. So this is exact. In the next example, up here in the x values, it's uniform, always going up by 1, but our first differences down here aren't always 2. They're pretty close though. We just have a few in there that change, and apologize for that, 2 different occurrences where it's 3. So there's an example of one that's approximate. It's not exact because it's not always 2, but it's pretty close. This brings us to another definition, which is determining whether data is discrete or whether it's continuous. So you see here a table that's describing the year and the retirement payment for somebody. It appears that you can retire after 20 years of service. So at year 21, you're given a retirement payment. At year 22, you're given a different one, and so on and so forth. Year 25, you would have $48,750 as your retirement payment. You cannot retire at year 21.3. Apparently with this company, you can only retire at the yearly mark. So that's an example of discrete data. In a graph, it would look like something along the lines of data like we see here, although this is not the data, the graph of the data that we're looking at. I only see points. I don't see values in between the points. It's not connected by a line because those values don't exist, discrete. Versus the picture you see here, which is continuous data. I've connected the data by a line because every single spot on that line represents a solution. So even the point that is right here, in between those others, is a point. So the difference between discrete and continuous, discrete, there are no values between the points, therefore not connected by a line. Continuous, connected by a line. Finally, I just want to review making a scatter plot with you. Making a scatter plot's not going to be any different than graphing points for a line. So I'm going to go ahead and put the years since 2000 running along the x-axis. I use this mark here to show that there's a little break in the data because I'm starting all the way at 20. Then along the y-axis I've got the population in millions. And each of the points that you see here on the graph correspond to a point that you see on the table. And that's all you need to do to make a scatter plot. I want you to take a few minutes and try some of the practice problems to make sure that you're understanding linear modeling, and then we're going to move on to regression and correlation. Go ahead and try the problem that you see on the screen. Make the dots and drag them around, and let's see how you do.